Hello developers, let's start developing. Today we're gonna take on the fourth task of the 2024 Advent of Code. Let's take a look at it. We need to search for Ceres, isn't that an asteroid? Ceres monitoring station. Oh yeah, we actually did that a few years ago. Word search, she needs to find X mass. Horizontal, vertical, we need to find all of them. Here, a few ways. So x mass, x mass, x mass, x mass. Okay, we have this, and we need to find all the x masses. Yay! Oh, this is gonna be kind of weird. So this is our initial input. Let's get onto this. Not day 3, let's take on day 4. So this is our input, and of course it's a matrix of words, matrix of characters. So the input processing will be okay by default. We do have a string array, and we need to write out some code. So of course we're gonna use the exact same logic that people actually use solving this thing. When you have to solve some kind of a word search in this way, you're searching for the first letter, and then in its neighbor you're searching for the second letter, and that gives you a direction, and then you check the third and the fourth letter. So I think that's what we are gonna have to do, and we have to do count the x's, the x masses. So let's maybe do it like this. We're gonna need to search through the array for all of the x's. So no, I don't want the input to be a string array. I would rather have it as a string array. So this is now a formal matrix. And in order to get that, I will say, well, take the lines and map each line and split it on everything. Let's just check whether we get oh, what we actually need. We should get the letters without any stragglers, so MMM, SXX, MASM. Looks about right. We don't have extra rows. MXM, ASX, yes. Looks like our input is okay. Since JavaScript and by extension TypeScript doesn't have a char type, we're still using the string type, but we can be sure that this string can actually be only one of XMAS things. So actually, let's do this type letter. I will call it, that will be either be an X, an M, an A, or an S, because Copilot sucked at this, so it's not gonna be a matrix of strings, it's gonna be a matrix of letter. Yeah, it's gonna work just as fine because we didn't actually change anything, just added some types. once it builds. And I think I forgot some changes. Oh, in the process input we're not returning that. We just need to specify, yes, this is an array of letters. The good thing is that now we know that we have one of that. So I will basically just loop through everything. Something along these lines. And this is gonna be our row index. This is not line, this is actually row, but we don't need that. We don't need the rows, we need the specific indexes. Yeah, we can use that. And if the letter is not an X, we can just continue, since we are only interested in the X's. Otherwise, we need to find the next three letters in any of 8 possible directions. So I will write some very ugly code that will do all of that. So horizontal forward. Actually, I might use the compass for this. It's not horizontal forward, it's gonna be east. And in order to do that, we will need to check whether, let's get the length and the width into some variables. So we will have the length, or the width actually, like that, and then we have the height or length, or however we want to call it. So that is the width of the thing and the height of the thing. So if we're moving east, we need to make sure that we are at least 3 less than the width, because if we are here, for example, we can, if there's an X over here like this one or this one, it's just not gonna have an Xmas to the east of it. So if the column index is less than width minus 3, then we need to check. We need to check 3 conditions, and we can check them at the same time. So I will say if, yes, exactly something like this. So C plus 1 should be M, C plus 2 should be A, C plus 3 should be S. And I think it's gonna be better if we do it this way. So I will remove the row thingy, since we have how to do it using the specific matrix notation, so our code will actually look a bit more understandable. Input of index. So the letter is not row of index, but is input of index. And then we have the next over there, and the next, and the next. So this is not some good code, but it's gonna be operational. And of course we need to have an Xmas counter. So if we have it over there and over there and over there, then we need to increase the Xmas counter. No, we're not continuing because we can have additional Xmas. We can have one X that triggers more than one Xmas, Christmas, or however you want to call it. I'm not totally sure that this line is correct, but I think it is. So now we're gonna kinda abuse Copilot because it will make it easy. It might have some bugs, but I still think it's worth it. So if we're going south, we need to make sure that the row index is less than height minus 3, and then we have an equivalent check. And then we need to go, we need to go southeast as well. So now we have both of those checks, and we're increasing both index and syndex, southwest. Yes, syndex needs to be bigger than 2. It needs to be at least 3 because we're going 2, 1, 0. Southeast, and then we have west. It doesn't want to go west. Yes, it does. And then we have northwest, and then we have north, and then we have northeast as well. And I think we have all 8 combinations. 1, 2, 3, 4, 5, 6, 7, 8. So those are all the cardinal points of the compass rose. And that could be it. Let's see. Yep, we found our 18 Xmasses. This is some totally ugly code, but it's kind of foolproof because we're just redoing the logic that a human will do. You find an X and then you say, is that an M, is that an M, is that an M? Basically, we try everything that we can, and we're trying to find all the X masses on the board. And this thing found me 2718 X masses. Let's see if that is the correct value. Yes, it is. We are correct, but to be honest, I didn't foresee any bugs happening. But let's see on how the second part. Did you misunderstand the assignment? No, we did not. Actually, you explained it wrong. But let's see how to explain it better. This isn't actually, it's an X. It's not an X mass puzzle, it's an X mass puzzle. 2 mass in the shape of an X. Oh. Huh. So now we're actually looking for a different pattern. Let's see if that tracks. So now we can have an A over here, and we're looking for, it can be like this, or it can be like this, or a number of other scenarios in the shape of an X. Yep. Can it be like this? Sure it can. Oh, it's the same as this one. And can it be like this? So let's say that if we have 2 M's around it, one M is here and one M is here, and then the S's are here. Yeah, that works. But can it be like this? Yes, this is invalid. as long as the two m's are not in the same line, this is valid. So we don't have an MAS. So this is actually kind of maybe simpler. Let's do the magic of copy and paste. That's part of the magic of Christmas. And now we're gonna check for something different. If the letter is an A, isn't an A, we're just ignoring it. And now instead of this monstrosity, we can just check. We can actually just ignore all the borders. So we can say something like this. If we are at the first line or the first column or the last line, last row or the last column, we're gone because it's not gonna be an Xmas. Otherwise, we need to make sure that there are no X's, so we only have, or A's. We only have two M's and two S's. Let's get them. Actually, let's do something like this. We need to find the good items. And those are only the M's and the S's. And is it possible to have three letters? So we want to make sure that we have only M's and S's over here. And an additional thing is that there are no situations when the opposite ones are the same. And that's the only decision, because if we have three M's, two of them will have to be opposite each other. If we have three S's, just the same. So if we say corners, we can have an array of corners, basically this, and not only that, I will literally just get them. And yeah, we can say this. Get the corners. If the corners have an X inside of them, we have a bad case. If the corners have an A to them, we're done, because that's not the case. If the first and the last corner are the same, actually let's move them up a bit, something like that, as we're going that one, that one, that one, that one. So if the first and the third corner, so this means that we have either some combination of M's and S's. If we have three M's or three S's, yeah, if we have one M, that means we have three S's. So the only way that the opposite ones are not the same is if we have 2 by 2 and they are not the same. So I can just say if the first corner is equal to the second corner, then we have a conflict, and we're not counting that. And additionally, if those corners are also the same, we have a conflict, we don't count. Otherwise, X mass counter gets increased, and we have what we were searching for. In some ways, this is more complicated than the first part. In some ways, it is less complicated than the first part. But let's see what happens. Actually, let's not do that. Let's go back to the previous example and see how many we are supposed to get. We are supposed to get 9 X masses. Let's check that. We are getting 9 X masses. That's great. So let's go back to the big input and let's check it. I'm quite unhappy with the code I wrote. I think it can be made a bit cleaner or better. But first of all, let's make sure that it's correct. And it is. Now we have completed day 4 with some ugly code that for the moment I will stay as it is, because that's the way I initially solved it, but we might go back to this and refactor especially this 60-line monstrosity. It's okay, it's kind of repetitive code, but that's the problem. If I need to change something in one of these branches, I will need to change this in 8 of these branches, and that is an issue. Anyway, if you like this solution, or if you didn't like this solution, mash those buttons over there and like, subscribe, comment, do whatever you want, and keep developing.